So in this video, I'm going to be combining polynomials together using the operations surrounding polynomials. So the thing about polynomials is that we're going to be combining the like terms. So in other words, x squareds go with x squareds, and x's go with x's, and just regular numbers, they combine together with regular numbers. So let's go into some examples. Let's say I have the polynomial minus 3x squared plus 2x, and I want to add that to 1 minus 5x. So the first thing that I'm going to do is distribute the signs to each of the terms in the polynomial. So when I distribute the negative, I end up with negative 3x squared minus 2x, and then I distribute the positive out. So I have plus 1 minus 5x. And then this is the part where we combine the like terms. So the negative 3x stays the same because there isn't any other x squared term to combine it with. But the minus 2x and the minus 5x, they combine together to form minus 7x. And then the plus 1 just stays the same. So we've effectively combined these two polynomials, these two groups, into one singular polynomial. So let's say I had 8y minus 2y squared minus 3y minus 8. So the order of operations that we learned, the PEMDAS and the GEMS method, still applies for polynomials. But you have to keep in mind that only like terms can be combined with each other. So, since I can't combine the two terms in the parentheses inside the brackets, all I have to do is distribute the negative. And when I do that, I end up with 8y minus 2y squared minus 3y plus 8. And now the parentheses inside the brackets are taken care of. There's no more multiplication inside the brackets, but I don't have any like terms to combine within the brackets, so now that's my cue to move outside the brackets and perform operations there. So I notice I have a negative sign out in front of the brackets, so I'm going to distribute that out too. And this will get rid of the brackets. So that gives me 8y minus 2y squared plus 3y plus 8. So I don't have any other y squared terms to combine with the minus 2y, so it stays out in front. But the 8y and the 3y can combine together, and when I do that, that gives me 11y, because 8 plus 3 is 11. And then the plus 8 just remains by itself. So notice how in each of these, the first term is always going to be the term that has the highest degree. And in this case, the highest degree is the squared exponent. So it goes out in front, and then any subsequent exponents go later into the polynomial. So let's say I had 2x times x squared minus 5x plus 6. So inside the parentheses, I can't combine anything because there's no like terms. However, when you go to multiply, you can do unlike terms together because you're multiplying them. So what I can do is I can distribute the 2x to each of these terms. And that's going to give me 2x cubed minus 10x squared plus 12x. And since there's no other like terms to combine with each other, this is the polynomial that we end up with. So essentially, the original thing that we had is just the factored version of this polynomial. So let's say I had 3x cubed minus 3 over 2 x squared plus 4. and I want to multiply that by a negative 3x. So you can use the distributive property in the backwards fashion too. So what I can do is I can distribute the minus 3x to each of the terms. And that's going to give me a minus 12x plus 9 over 2 x cubed minus 9x to the fourth power. So there's no like terms to combine in the polynomial, so these are the terms that we're going to end up with. However, I want to put the highest degree term out in front and then do gradually decreasing degrees from there. So the proper way to write this is minus 9x to the fourth power plus 9 over 2 x cubed minus 12x. And when I write a polynomial in this way, it's called standard form. So all of your answers should be in standard form once you're done. Let's say that I had 2x cubed minus 5x squared plus 10x minus 7, and I want to add that to 4x squared minus 7x minus 2. So the first thing I'm going to do is distribute the positive sign to each of the terms in the second group, because then I can get rid of the parentheses and then just start combining like terms. So this is going to give me 2x cubed minus 5x squared plus 10x minus 7. And when I distribute the positive sign, I get a plus 4x squared minus a 7x minus 2. And then I can start going to the highest degree and combining like terms and then gradually decreasing the degree. So for 2x cubed, I don't have any other x cubed terms to combine it with, so it just stays the same. And I can get rid of it. I like to cross out the terms as I go because it helps me keep track of what I'm combining and what I haven't combined yet. So moving on to the x squared term, I've got a minus 5x squared and a plus 4x squared. And that combines me to get a minus x squared. Because negative 5 plus 4 gives me a negative 1. Then I move on to the x terms. I have a 10x and a minus 7x, and that combines to get me a plus 3x. And then all that's left are the constant terms. And I have a minus 7 and a minus 2, and those combine to give me a negative 9. So this is what this polynomial would look like in standard form. All right, last example here. Let's say that I had 6x to the fourth power minus 20x squared minus x plus 3, and I want to subtract it from 9x to the fourth minus 11x squared plus 16. So the first thing I'm going to do is distribute this negative sign out. And that's going to help me get rid of the parentheses. So I'm left with 6x to the fourth minus 20x squared minus x plus 3 minus a 9x to the fourth plus 11x squared minus 16. And then I can work from the highest degree and combine the like terms, and then just keep decreasing the degrees until I get down to the constant terms. So I have a 6x to the fourth and a minus 9x to the fourth. So that's going to combine to give me a minus 3x to the fourth. And then moving on, I don't have any x cubed terms, so I move on to the x squareds. And I have a minus 20x squared plus an 11x squared, and that combines to give me a minus 9x squared. And then moving on to the x terms, there's only one of them, so I just bring it down, and that's a minus x. And then last, I do the numbers, the constant terms. So I have a 3 minus 16, that gives me a minus 13. And then that'll give me the answer in standard form. So I hope this video was helpful on how we combine polynomials and some operations that we do with polynomials. It's very similar to adding and subtracting real numbers, and the rules for algebra still apply, except when you add and subtract, you do like terms together. So x fourths go with x fourths, x squareds go with x squareds, etc. So I hope this video was helpful, and you'll stay tuned for the next video.